All right, so get this ready to dive into complex adaptive systems.
Yeah, complex adaptive systems.
Which is honestly kind of a mouthful.
Yeah, it is.
But it's such a cool concept.
It is a very cool concept.
And I'm so glad we're doing a deep dive on this.
Yeah.
I know you got a bunch of material.
I do. Actually, we're focusing on a specific course called Introduction to Complex Adaptive Systems.
Perfect, yeah.
So we're going to look at the syllabus and some background material for it.
Awesome.
And do a deep dive into this course.
Okay, so before we get into the specifics, what is this course all about? Like, what's the big picture?
So this course is designed to help you understand how the world works on a deeper level. From the planet itself down to ecosystems and human societies.
So it's not just about defining what a complex adaptive system is.
No.
It's about actually seeing those systems in action.
Absolutely. You'll be analyzing Earth, ecosystems, and human societies.
Okay, that's pretty broad. What specifically are we going to learn? Like, what are the learning objectives of this course?
Well, one of the key objectives is to define a complex adaptive system.
Okay, so that's like the foundation.
The foundation. And then from there, you can go on to analyze systems like Earth.
Got it.
Like the planet as a whole.
Okay.
As a complex adaptive system.
Cool. What else?
Another objective is to understand ecosystems as complex adaptive systems.
So we're zooming in.
You're zooming in.
On the whole planet.
Yes.
To specific ecosystems.
To specific ecosystems.
Like a forest.
Like a forest or an ocean or even a small pond.
Okay, that's cool. I like that.
Yeah.
What else?
And then the final objective that's listed here is to analyze human societies as complex adaptive systems.
Okay, so that's cities, nations, global systems.
Exactly.
Okay, so we're going from the entire planet down to ecosystems and then turning the lens on ourselves.
Yes.
That's quite a journey.
It is a journey.
All right, so we have a good overview of what the course aims to achieve. Now let's dig into the specifics.
Let's do it.
What are some of the defining features of a complex adaptive system? What should we be looking for as we analyze these different examples?
So one of the key characteristics is that these systems are made up of many diverse, interconnected parts.
Okay, so it's not just a bunch of random things thrown together.
No.
There's a relationship between those parts.
Absolutely.
Okay.
And another important feature is that the interactions between these parts aren't always linear or predictable.
So small changes can have a big impact.
Yes, very big impact.
That's interesting.
It is.
Okay, what else?
And perhaps most importantly, complex adaptive systems are constantly learning and evolving.
So they're adapting to their environment.
To changes in their environment.
Okay, I'm starting to see how this applies to so many different things.
It does.
All right, so we've got a basic understanding of what makes a system complex and adaptive.
Yes.
Now let's dive into how the course applies these concepts to specific examples.
Let's do it. Okay, so we've covered the basics of what makes a system complex and adaptive.
Right, those key characteristics like being made up of diverse, interconnected parts.
Yeah.
And the thing about how even small changes can have big ripple effects.
Exactly. It's not always a simple cause and effect relationship.
And of course, that whole concept of adaptation, how these systems are constantly learning and evolving.
Right, so they can adjust and keep functioning even when their environment changes.
It's amazing how resilient these systems can be.
It really is, and the course uses a lot of really cool examples to bring these concepts to life.
Okay, so let's dive into those examples because seeing real-world applications always helps me grasp the theory better.
Absolutely. So one of the first examples the course explores is Earth itself as a complex adaptive system.
Right. We talked about that earlier, how Earth's 4 major spheres are constantly interacting.
Yeah, the atmosphere, hydrosphere, geosphere, and biosphere, they're all interconnected.
And the course uses the example of melting glaciers and ice sheets to illustrate this.
Exactly. And this is such a powerful example because it shows how a seemingly localized event,
the melting ice?
Right, can have global repercussions.
Because it's not just about the ice disappearing.
No, it triggers a whole chain reaction.
Right. It affects ocean currents, salinity levels, marine ecosystems.
And those changes can then disrupt weather patterns.
Wow, it's like a domino effect.
It really is, and it all comes back to that idea of interconnectedness.
That everything's linked together in these complex ways.
And another example the course uses is the carbon cycle.
Oh yeah, that's a good one because it affects us all directly.
Right, and the course highlights how deforestation throws the carbon cycle off balance.
Because trees are like these giant carbon storage units.
Exactly, so when we cut them down, all that stored carbon gets released back into the atmosphere.
And that contributes to climate change, which then triggers a whole cascade of effects.
Rising temperatures, melting ice, changing weather patterns, it's classic complex adaptive system behavior.
It really drives home the point that even our actions as humans can have a huge impact on these systems.
And it's not always in a positive way.
Definitely food for thought.
Now, moving on from the global scale, the course then zooms in on ecosystems as examples of complex adaptive systems.
Oh, ecosystems are fascinating.
They are, and the course uses the predator-prey relationship between the lynx and the snowshoe hare to illustrate this.
I remember learning about that in school.
Yeah, their populations go up and down in these cycles.
But how did that show the principles of a complex adaptive system?
Well, it's not just a simple case of one animal eating another.
Okay.
As the hare population increases, there's more food for the lynx.
So the lynx population grows too.
Right, but then as the lynx population increases, they start to prey more heavily on the hares.
Which causes the hare population to decline.
Exactly, and then with fewer hares around, the lynx population also starts to decline.
So it's a self-regulating cycle.
Exactly. The lynx and the hare are dependent on each other.
And that balance is also influenced by other factors, right?
Absolutely. Things like weather patterns, disease outbreaks, the availability of other prey for the lynx. It all plays a role.
It's amazing how many variables are at play.
And the course also introduces the concept of keystone species.
Those are the species that have a really big impact on their ecosystems, right?
Yes, think of them as the cornerstones that hold the whole ecosystem together.
And the example they use is the sea otter.
In kelp forest ecosystems.
Right. Sea otters eat sea urchins, and sea urchins love to eat kelp.
Exactly. So if you remove the sea otters,
The sea urchin population explodes.
and they overgraze the kelp.
Which can destroy the kelp forest.
And that has ripple effects throughout the whole ecosystem.
It's amazing how one species can have such a big impact.
And it shows how human actions, like hunting sea otters to near extinction, can disrupt the balance of these systems.
Okay, so we've gone from the global scale of Earth to the intricate world of ecosystems.
And now it's time to turn the lens on ourselves and look at human societies as complex adaptive systems.
This is what I've been waiting for, because it's about understanding how these principles apply to us.
And the course uses the example of cities to illustrate this.
Oh, I can see how cities could be seen as complex adaptive systems.
They're constantly growing, changing, responding to new challenges and opportunities.
And the way they function has been shaped by so many things: technology, social movements, economics, politics.
It's a constant dance of adaptation.
And the course also explores the global financial system as a complex adaptive system.
Which is incredibly complex with all these interconnected networks of banks, stock markets, governments, businesses, individuals.
And the 2008 financial crisis showed just how fragile that system can be.
Right, a collapse in one part of the system, the U.S. housing market, triggered a global recession.
It's a stark reminder that even our human-made systems are subject to the same principles of complexity, interdependence, and adaptation.
Exactly, so hopefully you're starting to see the common threads running through all these examples.
It's like we're developing a new way of seeing the world.
And that's one of the most valuable things you can take away from this course, a new perspective.
So we've explored these fascinating examples. Now let's talk about the so what of it all.
Okay.
Why does understanding complex adaptive systems matter? What can we actually do with this knowledge?
Okay, so we've gone through all these examples of complex adaptive systems.
From the planet itself to ecosystems to human societies.
And I have to say, I'm finding it all really fascinating.
Me too.
But, at the end of the day, what's the point? Like, why does it matter that we understand these systems?
Well, that's a great question, and it's something the course really emphasizes.
Okay.
It's not just about the theory, it's about the practical implications.
So what are some of those practical implications?
One of the most important is recognizing the interconnectedness of everything.
Right, how everything's linked together in these complex ways.
Exactly, and that's crucial for understanding how to approach the big challenges we face today.
Like climate change.
Like climate change, social injustice, economic instability. We can't solve those problems in isolation.
We can't.
Because what we do in one area might have unintended consequences in another.
Exactly. And that brings us to another important takeaway.
Which is?
The potential for unintended consequences.
Right, because these systems are so complex.
It's not always a simple cause and effect situation.
So we might try to solve one problem.
And end up creating a new one somewhere else in the system.
That's a sobering thought.
It is, and that's why systems thinking is so important.
Being able to see the bigger picture.
Exactly.
Okay, what else? What other practical takeaways are there?
Well, the course also emphasizes the importance of adaptability.
Being able to adjust to change.
Right, because we live in a world that's constantly changing.
Climate change, technology, social and political shifts.
All those things are reshaping our world on a daily basis.
So if we want to thrive in this ever-changing environment,
we need to be adaptable.
Okay, so interconnectedness, unintended consequences, adaptability.
Those are some of the key takeaways.
And the course actually challenges you to go beyond just understanding these concepts.
It does.
It wants you to actually use this knowledge to make a difference.
Yes, to identify a system you're a part of.
And think about how you can contribute to positive change.
Exactly, because we're not just passive observers in these systems.
They're active participants.
We have the power to shape the future.
That's a powerful thought.
It is.
Well, I think this has been a really insightful deep dive.
I agree.
We've learned a lot about complex adaptive systems.
From the theory to the practical implications.
And I hope this has inspired our listeners to learn more.
Me too.
Because these systems are all around us.
And understanding them can help us make better decisions.
So go forth and explore the fascinating world of complex adaptive systems.
And keep an eye out for those patterns, those connections, those moments of change and adaptation.
You might be surprised by what you discover.
You might.
Thanks for joining us.
Thanks for having me.